Fantastic. Okay. Good afternoon, ladies and gentlemen. Welcome to our online webinar. It is a pleasure to have you here with us. Our topic today is laser cutting head contamination. This is the first of a series being conducted by Nitrogen Supply Company, and we are very delighted to have you here. We do have a few guests with us. We have James Rigby from Hall Manufacturing, and he'll be introducing himself very shortly, and myself, of course. Kevin is not able to make it today, but he has sent his apologies. So we look forward to hearing more from him, perhaps in the future. So yeah, without further ado, I will be starting. My name is Stephen Adiemi. I am director at the Nitrogen Supply Company. The aim of our business is to transform the manufacturing industry by aligning our business goals with our customers. This is done through innovative business models such as nitrogen as a service, which you may have heard of. Nitrogen as a service is a model where we give our customers nitrogen generators for free, and they pay us back based on how much they use it. This is fantastic because in months when their production is a bit lower than usual, they're not still paying high fixed repayments to us or to a finance company for that matter, and that frees up their cash flow. We also have James Rigby. James, would you like to introduce yourself, please, sir?
Yeah, thank you, Stephen. I'm James from Hall Manufacturing. We specialise in fine limit sheet metal, but we also cut up to 25mm thick, quite a broad range. We've got full value-added services, from welding to powder coating, assembly work, that kind of thing. We just Hallmark Manufacturing is quite a new business. It's been going for 6 months. Myself and Mark Hall, directors. That's us in a nutshell.
Fantastic. Thank you, James. So it seems like you've obviously been in the industry for a little while, running a few different laser machines as well. So I would love to obviously pick your brains a little bit later on your experiences on running all the different kinds of lasers over the years as well.
Yeah.
So today's agenda, we'll be looking at the CO2 lasers versus fiber laser cutting head, looking at some advantages or differences, where contamination can actually come from to affect these machines, both on the CO2 and the fiber, the difference in results, or what kind of effects or what actually happens on a CO2 laser when you get contamination compared to a fiber laser. And then we look at different preventative solutions to stop contamination occurring in the very first place. And of course, we're going to have our product review from NSC, followed by a Q&A section. So if you have any questions, please feel free to pop them in the chat or in the Q&A. And at the end, we'll do our very best to answer your questions. And if there's anything that we can't answer, we'll try and give you the answer to that after the webinar as well. So CO2 versus fiber optics. So James, like we said earlier on, you're in a unique position because you still have a older CO2 machine and you've got a newer fiber. So could you, from your user experience, explain to us what the difference is on the two when it comes to contamination or getting dirt or dust on your lenses?
Yeah, I mean, a CO2 machine is a lot more forgiving. You can get a lot more contamination on the lens and still achieve a relatively good cut. On a fiber laser, they're very sensitive to contamination. They get a slight bit of contamination on the lower lenses, and you'll be finding that you need to be cleaning them more often, and replacing them a little bit more frequently too.
Okay, of course, I get you. Yeah, I mean, we're not here to bash fiber lasers. I think fiber lasers certainly have the advantages. From your perspective, what are the positive advantages that having a fiber laser brings to your facility?
I mean, a fiber laser is, it's in terms of technology, it's light years ahead of the CO2 technology. We're experiencing cutting speeds in excess of 5 times when cutting aluminium. Obviously, you've got a much higher thickness range that you're cutting. You're using a lot less power. A fiber laser is that's what you want. You want over a CO2. Obviously, CO2 has got a little bit of an advantage, and you can cut certain materials, plastics and stuff like that.
Okay.
That you can't on a fiber.
Sure, and that makes sense. So that probably be the reason why you still got both machines to you the advantage off of both.
Yeah, I mean the CO2 machine that we've got is actually a punch combination machine. So we utilize the technology from the punching and the lasering for certain parts that we manufacture. So what it says, we're possibly looking at replacing the CO2 punch combo with a fiber punch combo.
That's pretty good. I'm sure a lot of people are taking notes. You'll be getting a few calls after this. So if we go to the next part, so on the CO2 laser, you typically have two different lenses. You sometimes on the higher powered ones, maybe 4 kilowatts and above, you do get a 10-inch lens sometimes. But it's typically a 5-inch lens and a 7.5-inch, and that would cover your broad range from 1 mil up to 20, 25 mil. But like you said, this is what a dirty lens could look like. That still actually works. And I didn't try to count those spots, but there's hundreds on there. And that operator has been very, very lazy and not changed his lens. You do get customers who actually run like that 24/7. But like you said, James, the CO2 machine is a lot more forgiving. On the other hand, though, with CO2s, you can get what is called a lens explosion. Personally, over the years, it hasn't happened while I was using the machine, but I have had customers call me with a lens explosion. It's like this, which is where the lens has been just stressed and just forget it, I'm going home. And it's just blown everything. And what you're really hoping is that all the dust or the debris from the explosion doesn't get back into the resonator. But if it does happen in this case, it's maybe a day's or 2 maximum engineer cleaning mirrors, realigning everything. And the bill, although still pricey relatively in comparison perhaps to a fiber laser, might still be a bit more. You can probably take it on the chin a bit more easier.
Yeah.
So while we were signing up, everyone signed up to the webinar, 66% of people said that they have actually already had to change their cutting head, and only 33% said no. So we're going to just run a very quick poll. And have you ever had a cutting head contamination? If you've got a laser machine, then certainly this would be a good answer. If you don't sell lasers, if you don't have a laser machine, obviously this might not be applicable, but it would be interesting to see. Okay, I'll just end the poll there and I'll share the results with everyone. Yep, so you can all see the results. It's very similar to how things are looking. 67% of you have had contamination on your cutting head, and 33% of us have not. Okay, and that sounds right across the board, similar to how it was when we were having customers sign up to the webinar. So when it comes to a fiber laser, as you can see, essentially, it is different from machine or from OEM to OEM, but the it's similar in the sense that you have a cover side at the top and a cover side at the bottom. And what these windows are doing is trying to protect the lenses in between them in the cutting head. But what's important to also note, though, is what contamination looks like on the fiber. So as James says, it can sometimes not be very forgiving. Can anyone actually spot the contamination on this lens? You'd be forgiven if you weren't able to see it. They're very, very small spots, but these two small spots can literally grind your production to a halt. This is why it's very, very important to put in every fail-safe that you can on your machine to stop contamination from getting on your lens or on your cover slides. Compare that to perhaps maybe a CO2 where you have 2 billion spots on it. The CO2 would still keep cutting, but those two spots, if not protected, could have a dramatic detrimental effect on your laser cutting speeds and even perhaps having to change your cutting head. So that moves us very quickly on to how do you check if you actually have any spots on your machine or if you have any contamination on your laser cutting head. James, have you got any experience with this? How do you guys actually check that perhaps on a daily basis? How often do you check it first?
Well, the fiber laser we've got, the system monitors the condition of the lens, and it'll show a percentage on so the operator can see, and it'll give a warning when it's close to the threshold, and then it'll also give another warning when it's exceeded that threshold and has to be changed or cleaned. We don't tend to take the lens. Well, we don't take the lens out of the machine unless the machine tells us that it's dirty, because you want to keep that head closed as much as possible. There's what we tend to do is we keep one set up clean in a sealed compartment and then just swap them out when it gives a warning. And then the laser operator, he's got a special torch that he shines through the lens to show up any dirty spots, and then he'll go through a cleaning process, acetone, and then he'll check it again. If he can remove the spots, then the lens will get put away in a sealed container to be used again. Sometimes you can't remove the spots, and then that just ends up going into the bin.
Of course. Yeah, that's right. Yeah, certainly checking it on a daily basis is something that is quite important, and it seems like the systems have advanced quite well to be able to tell you when you've actually got contamination in your lens. But certainly what we also recommend for customers to do is to retract the cutting head on the Z-axis, and where you've got the red Heaney beam or cat eye, whenever you see the black spots, that suggests that you've got contamination on something. It could be on the cover slides or even on the lenses. And what you're hoping, with fingers crossed, is that is only on the lenses. If it's on the top side, then it shouldn't really be on the top side, or anywhere else, to be fair. But then that means that you have to swap it out. So yeah, like we said, prevention is better than cure. Aside from perhaps maybe cleaning quite regularly, is there anything else that you do to sort of prevent contamination on your head or on your machine?
Yeah, so the operator on a daily basis, he'll wipe at the exterior of the cutting head down, just make sure there's no dust and anything splashed back up off the sheets that might have stuck to the head. Just keep it all nice and clean. When they're changing over gas, nitrogen gas, they'll clean the hose tails to make sure they're not introducing anything, because the head is purged with nitrogen. So just making sure that's kept clean, that you're not introducing contaminants. That's kind of what we do on a daily basis.
Yeah, fantastic. And you'd be right to be doing that. Um, we'd like to give you a couple of tips as well. When it comes to the fiber lasers, regular cleaning is essential. But there's also an ambient temperature difference that can cause issue on laser cutting heads, especially fibers. So on the fiber lasers, perhaps let's say you've got the cutting head at 22 degrees, but if the temperature outside the cutting head itself is elevated at, let's say, 32 degrees, so that means that there's a huge temperature difference between what's inside the laser cutting head and in the ambient temperature. And what that means is that you can get condensation on the inside of the laser cutting head instead. So in maybe summertime, for example, or during a heat wave, I don't know, you might have a service department just getting loads of calls because their cutting head or their machine's not cutting properly. And that'll be down to condensation occurring inside the cutting head because of the huge temperature differences from the laser cutting head and the outside temperature. Have you experienced anything like that at all? Or were you aware of that?
Not that I'm aware of, no. No.
Okay, cool. Yeah, that is something to note for all our viewers to also take away. And please feel free to ask any questions. At the end of the webinar, we'll have a short, brief question and answer session. And yeah, we look forward to answering any questions you may have. So I suppose then the question is, how do you prevent or how do you fix that problem where you've got a cutting head that's at 22 degrees and an ambient temperature that's at 32? And we just always suggest try and treat the temperature, or at least be aware that there's a difference. The worst case scenario would be if you had a machine that couldn't tell you the temperature inside the cutting head. That wouldn't be good. You need a machine that can analyze and tell you the temperature inside the head, as well as a normal thermometer of what the ambient temperature is as well. Right, okay. This is the time that we have been waiting for here at NSC. We do have a product to reveal today. Now, I'm excited. Last year, we revealed a product at the Association of Industrial Laser Users, and it went down very well. And this year, you have been a chosen few who have been privileged to see us reveal this brand new product. This product is something new to NSC, and it will be helping customers up and down the country who have the same issue that we've discussed about today. So without further ado, what I would love to do is share our new product. I hope you're as excited as I am. Listen. Yes, ladies and gentlemen, what we have there is our new product that is called Oil Shield. Oil Shield is a product designed to capture every source of contamination that can get into your laser machine from your gas lines. Now, gas lines is obviously one big source of contamination. We haven't been capturing any of these oils or any of these particles for a very long time, but NSC, together with our partners, together with our partners at Atlas Copco, we've developed a nitrogen, oxygen, air application with a specific filtration sequence that can stop every piece of oil, every particle, and every water droplet from ever getting into your laser cutting machine. Now, this piece of kit is a game changer because not only does it stop oil, it also prevents you from getting a very expensive bill on your laser cutting head if you have to swap it out. Put it in for 12 months, you won't have to worry about lenses or parts of your laser cutting head being contaminated. It's a quick installation. It's for high purity applications such as laser cutting, and it works even up to 50 bars. So you don't have to worry about losing pressure at your cutting head. So without further ado, please, round of applause for Oil Shield. Of course, I can't hear you clapping, but I'll do it for us. Thank you very much. This is our brand new product. If you'd like some more information on Oil Shield, or if you've got any questions on how it works, please feel free to ask me. Now, Oil Shield is a 3-stage filtration process. And essentially, this sequence has been designed by Atlas Copco in conjunction with Nitrogen Supply Company. And what we're doing here is removing oil and other particles in the correct sequence. Now, the reason why that's very, very important is because we have customers up and down the country who have oil on their lenses who do have filtration going to the machine. But what we're finding is because of this, the sequence isn't correct, the filters are being saturated with the oil and keeps on passing through. So this filtration sequence stops oil at every level down to 0.003 milligrams per meters cubed, without any contamination on your cutting lens. Yes. So James, please, could you tell us what's your first thought on Oil Shield as you have seen it being reviewed with you today?
Yeah, it looks like it could be a game changer. So, you know, the cost to replace a cutting head is quite expensive. So anything you can do to protect that and maintain production time, you know, it's a game changer.
Absolutely, yes, I agree. It is a game changer. It's something that should have been done for a long time. And some people are doing it as well. But like I explained, it's in the wrong sequence. So we've worked with well, the best in the world in Atlas Copco in developing something specifically for laser cutting applications. And it's very cost effective when you compare it to a cutting head. We have to put it in the panel just so we can protect the actual filters itself. And as time goes on, we're going to add new product features to it as well, sensing capabilities. And that box there is Oil Shield. And that will last you 1,000 hours without having to worry about any contamination. Brilliant. So, ladies and gentlemen, we are coming to that part of the webinar where if there are any questions from the audience, love to answer it. So if you have any questions, please feel free. I do have 1 or 2 here prepped anyway, but if you've got any questions about perhaps how much does it cost, or if you'd like some more information, yeah, please feel free and let us know. We'll be willing to share that with you now. Well, I've got one for you. Oh, nice. Okay, and when you add the cost of the downtime and maintenance costs, it looks like it's a great solution. What's the anticipated impact on customer satisfaction and performance improvement? Well, I think James is in a good position to answer this question. James, essentially, if your laser cutting machine doesn't have contamination, it means that it's producing parts, you're meeting your customers' orders, what does that mean to you as a sort of as an owner of a business to having your machine working?
Well, it's fundamental to the business because every product we produce goes through that machine. It's supporting so many other operations within the business that if the machine is down, it's not just one or two guys I've got stood still. I could have a whole team, 30, 40 guys, with looking at downtime. So keeping that machine going at all times is critical to the business.
Fantastic. Yeah. I mean, keeping the machine running is critical to the business. And we certainly agree with that here as well at NSC. And we think that a small investment in oil shield to protect your cutting head from contamination is something that you should be considered, because that will stop you from losing productions and perhaps maintaining your cash flow every month as well, because you're getting parts in and out. Final question, this will be from me. This is for you as well, James. How often were you changing your lens before you had any contamination or any breakdowns on your cutting head?
It really depends on what kind of materials that we were cutting. The lower lens, which is changed by the operator, it could change anything from every couple of weeks if he was cutting particularly rusty material or galvanized material. Tend to contaminate the lens a little bit quicker. Up to sometimes we've gone two to 3 months without needing to put a new lens in there. The top lens is a little bit different. That has to be done by the machine supplier. It's an engineer's visit. That's roughly 12 months. Well, that's about 1,000 cutting hours for us. So it's but like I say, it's an engineer's visit, so there's obviously a cost to that, plus additional downtime because your operator can't do it straight away. You've got to wait for an engineer to come and visit. So you know, anything that can be done to reduce contamination is a major plus.
Fantastic. Well, and there you have it. Anything that could be done to reduce contamination is a major plus. And so hear ye, go out and get your own filtration panel. Oil Shield is now available. It will be launching live on our website very shortly, so you can get a demonstration from us as well. Ladies and gentlemen, it has been a pleasure to have you with us on our maiden launch of Oil Shield. We do have some very distinguished guests in the audience as well. Thank you very much for spending your time. We look forward to speaking and sharing more data with you as the weeks and months progress. That's all that I have to say. Thank you, James. It's been brilliant speaking with you as well. Yeah, take care, and you're welcome. You're welcome. Yeah, take care and speak to you soon. Take care, guys.
Thank you.
Thank you.